Okay, so I'm Sonu, an NPTEL-PMRF TA for this course. I'm a Prime Minister Research Fellow at the Department of Mathematics, IIT Patna. I'll be taking live sessions every week on each Sunday, 7 to 8 p.m. We shall solve some of the problems related to the topics covered in that week. For example, today we'll be covering some very interesting questions relating to the content covered in week 1. I hope I am audible and visible as well. Can somebody confirm, please?
Yes, sir.
Okay. Every time I have to admit people. Actually, I have shared the meeting inviting link to the NPTEL team, but they have just shared the meeting link. So every time I have to admit if someone joins. So, okay. See. Let us wait for 1 or 2 minutes, then we shall start. Otherwise, it will be interrupting me.
Okay, sir.
Let some people join. Then we'll start. Meanwhile, if anyone of you wants to introduce yourself, you can. You can turn on your audio or turn on your camera also. And you can always speak in between. There is no problem. As we are waiting for 1 or 2 minutes to join other people's. Meanwhile, if anyone of you wants to introduce yourself, you can, please. Let me check the OBS studio if it is recording or not. Yeah. Okay. So I think we can start now. If someone will join, I'll have to admit that will interrupt, of course, but we'll manage. So I'll introduce myself again. I'm Sonu, an NPTEL-PMRF TA for this course, a Prime Minister Research Fellow at the Department of Mathematics, IIT Patna. I'll be taking live sessions on every Sunday, 7 to 8 p.m. We shall discuss some of very interesting problems related to the content covered in that week. For example, today we are covering some of the problems which are related to the content which you have already watched for week 1. So let us start. So before going to the problems, let me recall some of the topics, some of the theorems which Professor Jitendra has covered in week 1. So the first is Rolle's theorem. I hope whatever I am writing on the screen is also visible to all of you. So
Yes, sir.
okay. So Rolle's theorem says if a function f is continuous in closed interval AB and differentiable in open interval AB, and functional value at the endpoints is equal, then there exists at least one number C in open interval AB such that f dash C, f prime C is equal to 0. And the geometrical meaning can also be seen here in this graph. Here you can see the functional value of this function f, this is f function, at endpoint is equal. And this function we are considering continuous in closed interval AB, differentiable in open interval AB. Then there are 3 points, this point, and this point, at which the tangent is parallel to x-axis. That is, the differentiation of that function at that point is equal to 0. Right? This was the Rolle's theorem. The next, Lagrange mean value theorem, LMVT. This is upgraded, or you can say generalized version of Rolle's theorem, which says if a function f, people are still joining, so I have to admit them. So please bear with me. So LMVT says that if a function f is continuous in closed interval AB and differentiable in open interval AB, then there exists at least one C in open interval AB such that FB minus FA by B minus A is equal to F dash C. That means this is nothing but the slope of line joining these 2 points, this point and this point on the function. So it says that there will be at least one C in open interval AB such that the slope of that line segment joining those 2 points will be parallel to the slope of the tangent at that point, F dash C, right? In other words, it is also written, there is at least one tangent line in the interval that is parallel to line segment that goes through endpoints of the curve. So this is LMVT. We'll be using these theorems in our problems. That is why I'm recalling them, right? The next is generalized mean value theorem, which is Cauchy MVT. We sometimes says it like Cauchy MVT. So this talks about two functions, fx and gx. That is, we can also say this talks about parametric curve. So if fx and gx are two functions which are continuous in closed interval AB and differentiable in open interval AB, and g dash x does not vanish anywhere inside that interval. That is for, of course, a obvious region. We'll see. Then there exists a point C in open interval AB such that this satisfies. And this is nothing but this is slope. This is slope of this line, this I will say quotient line. So FB minus FA upon GB minus GA is the slope of this quotient line, right? And which is equal to slope of the tangent at some point C. So this says that there exists at least will be parallel to the slope of tangent at C point. Okay, and is theorem or Cauchy theorem. So we will not going to prove it easy. Can it using problem, right? So then the next, Taylor's theorem and Taylor's formula. People are still, it's 7 and people are joining. It's okay. I'll ask your team to send right link to all of you that it doesn't interrupt me. Okay, so next is Taylor theorem or Taylor's formula. So these are Taylor's formula, where this RF is the remainder term. So I'll go to the remarks. So this is the Taylor's formula. If in this formula, this is approximating. I hope the screen is visible to all of you. Actually, it's showing me on my laptop that it's delaying. It's properly. Like I'm writing something coming properly, or at the same time at which I'm speaking. Can somebody? Okay. Okay.
Yes, it takes some
Perfect.
time.
Taking some time.
Yes, sir.
Maybe network issue on the end or on your end. That might be possible. Okay. So this Taylor's theorem or Taylor's formula approximates a function fx around the point x naught. Okay, so I'm going to remark directly. So if we put x not equal to 0, that is, if we approximate a function around origin, then that Taylor's formula is called Maclaurin's formula. And if the remainder term Rnx, which we have mentioned here, if this Rnx tends to 0.
Now the screen is not sharing. Screen share.
Oh, okay. Let me share it again. I think there are some network issues. Is it visible now?
No, sir. For me, it is no. I don't know about others.
Okay. It should be visible, I think.
Only your picture is visible. Earlier it was fine.
I think there are some network issues. Is it visible now?
Yes.
Some are saying visible, some are saying not visible. I'm connected to Institute's Wi-Fi, so there should not be any problem, I think.
Okay, sir.
But if
please continue, then we will check it.
Okay. By the way, this session is being recorded, so and will be put on my YouTube channel. I think NPTEL team will also share the link, or you may also search on YouTube. It will be there.
Now it is okay, sir. Now for me it is coming.
It is visible.
Visible now.
Visible,
now it is
right?
visible. Yes.
Okay.
Perfect.
There might be some network issue then. Okay.
Sir.
So what I was saying that if the remainder term Rnx, which we have seen in the last slide, this Rnx term tends to 0 as n tends to infinity, then the formula which we get will be Taylor's series, right? And again, if in this formula we put x not equal to 0, then it will be Maclaurin's series. So these are some of main theorems which Professor Jitendra has covered in week 1, and I hope you all have watched the videos of week 1. So based on these theorems, we will be doing some of the problems. So let us start with problem 1. Is it visible? Question number 1?
Yes, sir.
Okay. So question 1 is kind of, can somebody tell what is question 1 asking for? Anyone? We have seen Rolle's theorem, and it is asking for that point which we stated in the theorem. Which point? The value of C, at which f dash C is equal to what? Can somebody tell?
0.
0, right. So fx is given this. So first we have to see if fx is satisfying Rolle's theorem or not. Although it has been mentioned in the question that satisfies the conclusion of Rolle's theorem, right? We can do it directly, but let us see if it is satisfying or not. So fx is this. I am rewriting fx equal to x square plus 3x into e raised to power x by 2, right? So f dash x, applying chain rule, let us keep it as it is, and differentiating e raised to power minus x by 2. It will be e raised to power minus x by 2 into 1 by 2 plus, now differentiating the first part, 2x plus 3, and keeping the second part as it is, right? So if we take 1 by 2 common of all and take e raised to power minus x by 2 common, then what will be in the bracket? So it will be x square minus x minus 6. Just simplifying the this term. So we will get f dash x is equal to this, right? Now this f dash x exists in the interval close interval 0 minus 3 to 0. Exist means it is not going to infinity or minus infinity on the points in close interval minus 3 and 0, right? So if it is differentiable, so f dash x is f dash x exists for all x belongs to minus 3 to 0. This implies fx is continuous also, because every differentiable function is continuous in closed interval minus 3 to 0, right? And the other thing we can also see, if f minus 3 is f minus 3 will be, because our fx was initially it was x into x plus 3 e raised to power minus x by 2, right? So f minus 3 will be 0, and what was the interval? Minus 3 to 0. So f0 will also be 0. So this implies on functional value on endpoints is equal to 0. This means it satisfies all the properties of Rolle's theorem. Now we just have to find f dash c. We have already found out f dash x, which was minus 1 by 2 x square minus x minus 6 into e raised to power minus. So just putting c there, we will get minus 1 by 2 c square minus c minus 6 into e raised to power minus c by 2 equal to 0, according to Rolle's theorem. Now from here, we can find out c square minus c minus 6 equal to 0, because this will be non-zero and this is also non-zero, so we can put it on the other side, right? From here, open interval minus 3 to 0. So this value of c will not be counted. So c will be minus 2. So our option C will be correct. So question 1, if anyone of you having some doubt in this, you can ask. Otherwise, we will proceed to question number 2. So question 2 is little, you can say, modified version. We have to see it from another angle. So this question is having fx as a piecewise function, right? That means fx is minus 2px plus 3 when x is less than equal to 0, and fx is 2x square minus x plus q when x is greater than 0. Okay, so it's saying for some p and q in R, the function f is defined as this. If f satisfies all the conditions of Rolle's theorem, it has already given that it is satisfying all the conditions of Rolle's theorem in closed interval minus 1 to 1, then the value of 2p minus q is, what will be the value of 2p minus q? Okay, so let us do it. So it has been given that f satisfies all the conditions of Rolle's theorem. So therefore, fx will be continuous in closed interval 1 to 1. Fx will be differentiable in minus 1 to 1 open interval, right? And functional value of f at endpoints, that is minus 1 and f1 is equal. These three conditions it will satisfy, right? Now, From this function, we can clearly see f is continuous and differentiable in interval -1 to 0 open union 0 to 1, right? It is having problem at 0 that we have to check, right? So the only ambiguity is present at x equal to 0. So however, this is given that it is satisfying Rolle's theorem, right? So it will be continuous everywhere, but we let us check. Okay, so now at x equal to 0, if it is continuous, then limit x tends to 0 plus, that is right hand limit of fx, will be equal to limit x tends to 0 minus, that is left hand limit fx will be equal, right? From this condition, if you see here, if we are approaching x, our fx was, let me write fx here for your reference. So fx is 2px plus 3 when x is less than 0, and it is 2x square minus x plus q when x is greater than 0. So if we are approaching x from positive side, from right hand side, then fx will be this, right? So at x equal to 0, this will be q equal to, and if we are approaching 0 from left hand side, uh, this is 0. If we are approaching from here, then f, it is giving q, and if we are approaching from negative side, then it is giving 3, right? So this will give us q equal to 3, right? Then the next condition, f is differentiable at x equal to 0. So at x equal to 0, for differentiability, limit x tends to 0 plus f dash x must be equal to limit x tends to 0 negative f dash x, right? Now f dash x, if we are approaching from 0 positive, so this will be 4x minus 1, right? 4x minus 1, and at x equal to 0, this will be gone 0, so it will be minus 1 plus, and if we are approaching from negative side, then it will be minus 2p, right? So this will give us p equal to 1 by 2. So we are having p also and q also, and the question was asking the value of 2p minus q. So what will be the value of 2p minus q? It's just 2 into p by 1 by 2 minus q is our 3, so it will be minus 2, right? So the option number B is correct. I hope everyone has understood this question. So now let us go to question number 3. So question 3, if you see on the right hand side here, if you see on the right hand side of the options, you will see somewhat relating to the LMVT, right? So this is giving us a hint that we have to apply LMVT here, right? So here, by seeing the options, we let fx equal to sine inverse x. Okay, this we are assuming. So this function is clearly, fx is continuous in closed interval pq, right? And differentiable in open interval pq. So applying LMVT, what does LMVT says? Can somebody tell? Somebody please state what LMVT says. We have just seen on beginning of this session. There are some messages in chat. Okay. Yeah, you can always respond through chat also, and through unmuting you. You can respond answers, or you can respond any query. You can ask any query in between. Somebody please state LMVT. What LMVT says? We have seen on the beginning of the session. So we are applying LMVT for this function fx, sine inverse x. Okay. So it will say that we will have some C belongs to open interval PQ such that, okay, someone is joining now. Okay. So it will have C in open interval PQ such that FQ minus FP upon Q minus P will be equal to F dash C. Right? So from here we can write sine inverse Q minus sine inverse P upon Q minus P will be equal to F dash C. So what will be the derivative of sine inverse x? It will be 1 upon 1 minus x square. So at C it will be 1 upon 1 minus C square. Right? So I'm giving this equation number 1. So next, now P is belonging, C is belonging in between P and Q, open interval P and Q. So this implies 1 minus Q square will be less than 1 minus C square less than 1 minus P square. This we can write. And if we reciprocate all of them, the inequality sign will be changed. So 1 upon 1 minus P square, this will come this side, less than 1 upon 1 minus C square, 1 upon 1 minus Q square. I hope this is understandable to all of you. So this implies we can write Q minus P upon, we are just using equation number 1 here, writing the value of 1 upon 1 minus C square in between. So it will be Q minus P 1 minus P square. Let me write only 1 here. So this will be the value sine inverse Q minus sine inverse, from equation 1 we are using it. It was Q by Q minus P less than 1 upon under root 1 minus Q square. Now if I multiply with Q minus P on each side, so it will be Q minus P and it will be Q minus P. And this is what given in the option. So our option number, which option will be correct here? Anyone in chat, or anyone can say which of the options? I'll say, because there will be 2 options which are correct. It's clearly, here it is greater and here it is less, right? So 1 minus P square, it is greater than. So option number
Option A.
B and C, right?
B and C.
B and C. Because from this inequality we can see this is clearly option number B, this option number B, and if I write it from another color, this will be option R, C. You can see, right? If any one of you having some issue here, you can always ask. Otherwise we will move to question number 4. In question 4, it's clearly mentioned that you have to apply LMVT. We don't have to bother about that. In last question, we have to figure out that which theorem we have to apply, and that we figured out from the options, right? So question number 4 says that use LMVT. Let me change the color. Use LMVT to find a point on parabola y equal to 2x minus 3 all square, where the tangent is parallel to the chord. Chord is like a line segment, we can say, joining 3, 0 and 5, 8. Okay, so this question is somewhat easier because we have already seen a one of the difficult question based on LMVT. So it will be somewhat easier, right? So yx is clearly a polynomial. It is parabola, of course, but it is a polynomial. And we all know polynomial is continuous and differentiable. So this will be continuous in closed interval 3 to 5 and differentiable in open interval 3 to 5, right? So we can apply LMVT. So according to LMVT, there exists C belongs to open interval 3 to 5 such that y dash C will be equal to y, the interval, the endpoint y5 minus y3 upon 5 minus 3, right? So from here, y is this. So y dash will be, y is our, what was y? Y was 2x minus 3 square. So y dash will be 4x minus 3, right? Okay. So it will be 4x minus 3. So at C, y dash C will be 4c minus 3. And it will be equal to, from here, y5 will be 5 minus 3, 2, and square 4. So it will be 8 minus y3 will be 0 by 2. So it will be 4. So y dash C equal to 4. So from here, 4 cancelled and C will be 3. So our option number, so no, it is asking where the tangent is parallel to the chord 3, 0. So it's, see, in geometrical meaning, we have seen that there will exist one point, this C, where the tangent will be parallel to the tangent of that chord, right? So C is 3. So that point will be CYC. That we have to answer. So C is 3 and YC will be, if we put x equal to 3, x equal to C is 3. So that will be 3, 0. Because YC will be 2 and 3 minus 3, right? 0. So it will be 3, 0. So our answer will be B. B option is correct. Right? I hope it is clear to all of you.
Yes, sir. Yes.
Okay. Okay. So now let us come to question number 5. Question number 5 is based on Cauchy mean value theorem, that is generalized LMVT, which we have seen at the start. Let me go there again. So this was generalized mean value theorem. I hope it is visible to all of you.
Yes, sir.
Cauchy mean value theorem. So it says that if we take a parametric curve, this is parametric curve, then the tangent of this quotient line will be equal to the tangent at some point C, right? FB minus FA upon GB minus GA equal to F dash C upon G dash C. This Cauchy mean value theorem says. So now let us come to our question, which is question number 5, right? So question number 5
me,
says
sir.
that, hello?
Sorry for disturbing, sir. So, once again, can you tell me that y of C is 0? How we took that y of C is 0? Once again, please explain me.
Y of C?
Yeah.
Okay.
We took.
Yeah.
Okay.
So see, our the function was given 2x minus 3 square. Okay. So our function was y equal to 2x minus 3 square, right? And C value is 3.
Yeah.
We are getting C equal to 3. Okay. Well,
Yes.
I made a mistake here. Thank you so much. What's your name? Please.
Pratibha.
Yeah, Pratibha, thank you so much for pointing out. I was cancelling this and treated at 0. So this will be C minus 3 equal to 1. Thank you so much for pointing it out. So it will be C equal to 4. I was thinking that there is some mistake because I knew the answer. And okay, thank you so much. So it will be C equal to 4. So the point will be 4 YC. Now YC will be 2, 4 minus 3 square. So it will be 2. So 4, 2. So answer will be 4, 2. Thank you, Pratima, for pointing it out. Okay, now let us come to question number 5. So question number 5 says that the value of C in Cauchy mean value theorem for function fx equal to e raised to power x and gx equal to e raised to power minus x on closed interval mn is which of these will be the value of C? Okay, so Cauchy CMUT says that fn minus fm upon gn minus gm, okay, will be equal to f dash c upon g dash c, right? So from here fn will be e raised to power n, fm will be e raised to power m upon e raised to power minus n minus e raised to power minus m equal to f dash c will be e raised to power c and g dash c will be minus e raised to power c, because gx is e raised to power minus x. Okay, so solving this we can get e raised to power 2c equal to e raised to power m e raised to power n, just taking common e raised to power n and cutting that, and from there we can get this. Okay, so now it can be written as e raised to power 2c is equal to e raised to power m plus n, and then 2c equal to m plus n, taking anti-logarithm, and then c will be m plus n by 2. And this is what the question was asking. So option number A will be correct option. Okay. Then let us come to question number 6. And question 6 is on limit. And while recapping on the initial slides, we have I have forgotten to include the intermediate forms. I hope you have watched in the week content. So we'll be doing this question. It is based on limit L'Hopital rule. So it is asking that if limit, is someone saying something? Okay. Thank you, Kotha Nandraman. I'm pronouncing it, I think, correctly. Thank you for pointing out that again. And if someone's saying something, okay. So it is given that limit of this function equal to 1, then the value of alpha plus 3 beta is. So this is given 1 equal to limit x tends to 0, x 2 minus alpha cos x plus 2 beta sine 2x upon x cube. So this is clearly 0 by 0 form. If you see here, if we tend x equal to 0, so it will be 0, and on denominator it will also be 0. So 0 by 0 form. So applying L'Hopital rule, using L'Hopital rule, it will be 1 equal to limit x tends to 0. So differentiating it, so it will give us applying the chain rule, we can do it. So it will be 2 minus alpha cos x. I'm writing the simpler version here. It will be 2 and then alpha. So this will give us plus alpha x sin x plus, and this term will give us 4 beta cos 2x. I hope I have done it correctly. Check it, and if it is wrong, please mention. And then it will be 3x square on the denominator, right? So applying L'Hopital rule, we will get this. Now the limit will exist. Okay. So this limit will exist only if this term, limit of this term is equal to 0. Okay. Because if this goes to 0, then it will be again the indeterminate form, right? So this limit, which limit? Limit x tends to 0, the numerator 2 minus alpha cos x plus alpha x sin x plus 4 beta cos 2x is equal to 0, right? So this will give us 2 cos 0 is 1, 2 minus alpha plus this is 0. This will give us 4 beta equal to 0, right? So I'm giving it equation number, let us 2, and this was our equation number. Not this. This one is 1. Okay. So now using this 2 in 1, and using L'Hopital rule at the same time. So it will give us 1 equal to, from equation 1 we are writing it. Okay. So it will give us limit x tends to 0, differentiating 2 alpha sin x is 2 alpha sin x plus alpha cos x minus alpha x sin x minus 16 beta cos 2x upon 6. Sorry, this is 1. So 6x. Okay. Applying L'Hopital rule here again, we will get this equation. Okay. Now limit approaching to 0 will give us, this will be 0, this will alpha, and this will give us 0, 0, and 0. Am I making some mistake? Can somebody see here? This will be 2 alpha sin x plus alpha x. Sorry, here it will be alpha x. See, here we are applying L'Hopital rule. So this will be x, alpha x, this term, alpha x cos x. Okay. So now if we approach x equal to x tends to 0, then this will give us 0 by 0 again. Okay. Then again applying L'Hopital rule will give us limit x tends to, so we are applying 3 times L'Hopital rules 3 times. Okay. So x tends to 0, this will give us 2 alpha cos x plus alpha cos x minus, again applying that chain rule, alpha x sin x, and this will give us 16 beta cos 2x upon 6. So this will give us 1 equal to 2 alpha alpha 3 alpha minus 16 beta by 6. So from here we will get 3 alpha minus 16 beta minus 6 equal to 0. This is equation 3. Now solving this 2 and 3, we can get value of alpha and beta. Okay, so that I'm leaving for you guys. This question is somewhat, calculative type. So do it again, and you will find these two equations: 2 minus alpha plus 4 beta equal to 0, and 3 alpha minus 16 beta minus 6 equal to 0. And then solving these two equations, you will get value of alpha and value of beta. And then, sorry, it's not 0. And then it is asking value of alpha plus 3 beta. That you can find out easily. Okay, so this I am leaving for you to check. Because we have just only 15 minutes and we have to cover other 4 questions also. So I'm telling the answer here, it will be C option, so that you have to verify if C option is correct or not. Okay. So now let us come to question number 7. Question 7 is again based on limit approach. So it's saying that fill in the blank with appropriate option. If fx is differentiable at x equal to 0 and f0 is 0, then find the limit of this. Okay, so the function is we have to find limit of x tends to 0 e raised to power fx minus 1 upon fx. Okay, and it is given that f0 is 0. This is given, f0 is 0. Okay, so if we approach x tends to 0, so it will be 1 minus 1 upon f0, and f0 is 0 already, so 0 by 0. So this is 0 by 0 form. Okay, so applying L'Hopital rule will give us limit x tends to 0 f, applying L'Hopital rule, so it will be e raised to power fx and f dash x upon f dash x. Okay, as it is given fx is differentiable, so we can obviously apply L'Hopital rule here. So then we will get limit x tends to 0, e raised to power fx will be e raised to power f0. Okay, and e raised to power f0 is 0, so e raised to power 0 is 1, right? So this will be 1. This is 1. Limit x tends to 0, e raised to power fx is 1, and this is cut down. So this will give us value of the required limit 1. Okay, and option B is correct here. Okay, now let us come to question number 8. So we will be now using what we have recalled, that is Taylor series and McElrange series. So question 8 is based on the Taylor series. It is saying that use Taylor series to expand the function this polynomial fx equal to x cube minus 4x plus 3 in powers of x minus 2, that is this. Then the value of alpha plus beta plus gamma plus delta is equal to. Okay, so it is clearly saying that we have to expand this function fx in the power of x minus 2. Okay, so given function is fx equal to x cube minus 4x plus 3. I can write fx equal to fx minus 2 plus 2. No harm. then this implies fx equal to, I'm expanding using Taylor's series, so fx minus 2, this x minus 2 plus 2f dash x minus 2 plus 2 square upon 2 factorial f double dash x minus 2 plus 2 cube by 3 factorial f triple dash x minus 2 plus so on. Okay, I'm giving it equation number 1. Then now f dash x will be 3x square minus 4, and if I write it in terms of f dash x minus 2, so it will be 3x minus 2 square minus 4. Okay, I hope it will give the same value. Okay, now f double dash x is equal to 6x, and if I write it in terms of x minus 2, it will be 6x minus 2. Okay, and similarly f triple dash x will be 6, and if I write it in terms of x minus 2, it will be 6 because constant. F 4 time derivative of f will be 0. Okay, so from equation 1, which equation? This equation, we can see that fx will be, putting these values in equation number 1, we will get fx minus 2 plus 2 into f dash x minus 2 is 3x minus 2 square minus 4. Okay, and plus 2 square by 2 factorial into f double dash will be 6x minus 2, so 6x minus 2, and then plus 2 cube by 3 factorial into 6 f triple dash. Okay, and plus next terms will be 0 because f 4 time derivative is 0. Okay, so now simplifying this, we will get fx minus 2. What was the fx minus 2? Value of fx minus 2 was, if I put x minus 2 in place of x, so it will be x cube minus 4x minus 2 plus 3. Okay, plus 2 into this value, and 2 into this will be, I'm writing it simplifying, 6x minus 2 square minus 8 plus 4 by 2 into 6x minus 2, and this will be plus 8 by 3 factorial is 6 into 6. Okay, okay, so now simplifying it, we will get fx equal to x minus 2 cube plus this 4x minus 2, and from here we will get to 12x minus 2. So this will be 8x minus 2 plus this 6x minus 2 square plus this 3. Okay, right. So now this 8 cancelled. Then this we have find out that fx, I'm writing it in another color. So fx, we have got x minus 2 cube plus 6x minus 2 square plus 8x minus 2 plus 3. Now comparing it with our given fx in the question, we will get alpha equal to 1 and beta equal to 6, gamma equal to 8, delta equal to 3. Adding all these, we will get 18. 7, yes, 18. So question option number C will be correct. I hope you have understood this question. Now let us come to question number 9. We are having only 5 minutes left. So we'll do immediately question number 9 and the 10. So it is saying that f0 is 1, f dash 0 is -2, f double dash 0 is 3, and f n dash 0 is 0. For all n greater than equal to 3, and all its derivative exists and are continuous between x0 and x2. Then use Maclaurin's series to find the value of f2. So Maclaurin's series is nothing but the Taylor series around 0 origin. Okay. So Maclaurin's series is fx equal to f0 plus x f dash 0 plus x square 2 factorial f dash 0 plus so on. Okay. So this is Maclaurin's series of fx around 0. Now, considering x equal to 2 will give us, because we have to find the value of function at 2. So f2 will be f0 plus 2 into f dash 0 plus 4. It will be 2 only, f dash 0 plus 2 raised to power 3 will be 8 by 2, 4 into f triple dash 0 and so on. Okay. Now putting these values, these given values, we will get fn 0 is 0 for all n greater than 3. So this will be vanished 0, and putting all these value we will get 1 plus 2 into -2 plus 2 into f dash 0 is 3 plus 0. Okay, so it will give us the value 3. So f2 will be 3. So option D is correct. Now let us come to question number 10. Question number 10 is again based on Taylor's polynomial. Okay. I'll write first. It is asking us in approximate value of y2 from Taylor's polynomial third degree. Okay. So Taylor's polynomial of third degree is yx plus h equal to yx plus hy dash x plus x square by 2 factorial y double dash x plus h cube by 3 factorial y triple dash x. Okay. Now it is given that dy by dx is 2x plus 3y and y1 is 1. Okay. So d square by dx square, that is derivative of dy by dx, will be 2 plus 3y derivative dy by dx, which will be equal to 2 plus 3, putting value of dy by dx again to 2x plus, I'm writing it simplifying, 6x plus 9y. And d third derivative of y will be d cube y dx cube equal to, it will be 6 plus 9 dy by dx. Again, putting value of dy by dx will give us 6 plus 18x plus 27y. Okay. Now we also have y1 equal to 1 and y dash 1 equal to, y dash was 2x plus 3y. Okay. So at 1 it will be equal to 5. Okay. Because y1 is 1. Okay. So it will be y dash 1 will be 5, y double dash 1 will be 9 and 8, 17, and y triple dash 1 will be 51. Okay. So now putting all these value in our polynomial of third degree, we will get y2 will be y1 plus y dash 1 plus 1 by 2 factorial y double dash 1 plus 1 by 3 factorial y triple dash 1. Putting all these value, we will get 1 plus this 5 plus this will be 17 by 2 plus 51 by 6. Simplifying it, we will get 6, 12. This will be, I think, 23. Okay. 2 plus 10. Okay. 23. So the answer will be C. Okay. So we have done 10 questions in today's session, which are related to the content which has been covered in week 1. I hope it will be helpful to all of you to solve the assignment questions of week 1. Someone has asked a question. Where we find these questions? Okay, these are questions taken from previous year of this same course. Okay, because I haven't taken questions from the current assignment, because I believe that it will be unethical to discuss the questions of current assignment here. Okay, that is why I'm taking questions from previous assignment, and we are discussing here. You can always contact me on any social media, or you can always visit my website also on onuslamba.com. We can discuss any query or any question if you have. Okay, and this session, I have recorded this session as per the guidelines received from NPTEL and PMRF. I'll be putting this session on my YouTube channel. You can find out my YouTube channel on YouTube by searching Sonu Lamba IIT Patna. It will show. Okay, and you can share this session with your friends who could not join today's session. I'm thanking to all of you for being such a good learners here. This is, a collaborative teaching learning experience for me. Like Pratibha has pointed out a question, like Kotha Nandraman has pointed out the mistake. So this should be a collaborative teaching learning experience. I thank you all of you. Thank you so much. Pranam.